All right, so we are going to add with unlike denominators. Okay, so yesterday we added with like denominators, right? And that was pretty simple because we know when we add or subtract, we need to have the same denominator. So if they already had the same denominator, we could just combine our like terms. Now when they don't have the same denominator, what are we going to have to do first? Make them the same denominator, right? So let's say we have 8y over 10 plus 2y over 5. So currently the denominators are 10 and 5. We need to make these the same. Okay, so to make these the same, there are two ways you could do it. And one of the ways is certainly to multiply 2y over 5 by 2. So we'd multiply both the top and the bottom by 2. So now we have 8y over 10 plus 4y over 10. Now they have the same denominator, so we can combine. So what's 8y plus 4y? Yep. So now we've got 12y over 10. And can 12 over 10 simplify? To 6 over 5. So this would be 6y over 5. Is that okay? All right, now let's put some variables in there because we're not just going to work with numbers, right? We're going to work with variables. So x plus y over xy squared plus 3x plus y over x squared y. So we need to make the denominators the same. So we have an xy squared and an x squared y. Well, so here we have an xy squared, right? Here we've got an x squared y. So first off, in the second denominator, how many x's do we have? We've got 2 of them. How many do we have in the first denominator? Only 1, which means we need another 1. So we'll multiply the first one by x for sure. Okay? So now in the first fraction, we have 2 x's, and how many y's do we have? 2. Second denominator, we have 2 x's, but only 1 y. So we need to multiply this by y. Okay, so now, rewriting the problem out, if I multiply this by x, I have to make sure I distribute the x to both the x and the y. So we'd have x squared plus xy, good, over x squared y squared plus, to make sure we distribute the y to both, so 3xy plus y squared over x squared y squared. Now we have the same denominator. So now we can just gather our like terms. So we know it's going to be over x squared y squared. And are there any like terms for x squared in the numerator? Okay, so leave that the same. How about xy? Yep. xy plus the 3xy gives us the 4xy. And then we would still have the plus y squared at the end. And there we're simplified. Does that make sense? Okay. Well, let's get some other type of stuff in the denominator. So we also are dealing with different factors like, x plus 2 and things like that. So let's look at some of those. So here we have 2 over x plus 5 plus 3 over 4x. So these two denominators, x plus 5 and 4x, they really don't have anything in common right now. Okay, that would be like having the denominators 3 and 7. So what do you do when the denominators don't have anything in common at all to get them the same?
Multiply them by one another.
Yeah, multiply them by each other. Okay, so this one's x plus 5, that one's 4x. So the first fraction I would multiply by the 4x. And the second fraction, what would I multiply by? Not 5x, x plus 5. Okay, so then what will my first fraction end up being here? 4x times 2, what is that? 8x over, to take 4x times the x plus 5, what will that give us? Good, 4x squared plus 20x. Plus, okay, 3 times x plus 5, what does that end up being? 3x plus 15 over, now we already figured out what the denominator is. 4x squared plus 20x. The denominators are now the same, so we can just gather our like terms together. So we know it's all going to be over 4x squared plus 20x. And when we gather our like terms together, what do we have? Yeah, good. 11x plus 15. 8x plus 3x is 11x. Then we have plus 15. That one okay? Everyone understand why these two were not alike whatsoever? The first fraction, x plus 5, this is attached with addition. Second one was attached with multiplication, so there was no way we could have even made one look like the other. Okay. So let's look at 4. 5 over z plus 4 plus 3 over 3z plus 12. Okay, good. So these look like they could be similar. Z plus 4 and 3z plus 12. These look kind of the same, right? They both have addition in between. And if you take a look at z plus 4, what could you multiply each of these by to make it 3z plus 12? You could multiply them each by 3. So we would times this by 3. Okay, so then we have our first fraction is now changed to 15 over 3z plus 12. Second fraction we didn't have to do anything to, so that one stays plus 3 over 3z plus 12. So when I combine this together, what do I end up having? Yep, 18 over 3z plus 12. I'm going to argue that this is not simplified. Why? Yeah, everything is divisible by 3. So we could take a 3 out of the denominator. So it would be 3 times z plus 4. And then 18 over 3 we could simplify. And how would 18 over 3 simplify to 6? So this is 6 over z plus 4. Does anyone see how we could have went from this first problem to the ending simplified answer in just going about it slightly different? Right here, the other way we could have looked at this was 3z plus 12. We could have taken a 3 out right here and made it 3 times z plus 4. And then we could have simplified our 3's down, so changed it to 1 over z plus 4. Then 5 over z plus 4 and 1 over z plus 4, they have the same denominator. And we would have gotten to the simplified answer. It doesn't matter which route you go, you're going to get the same ending answer. Is that okay? All right. Let's do one that's got some factoring now involved. So 7 over a squared plus a minus 2 plus 5 over a squared minus 4a plus 3. Currently, do the denominators look the same? I mean, they're both as a trinomial or as a quadratic here. But we can't just multiply the first one by a number to get the second. Okay? So here, I'm going to suggest that we factor these denominators, because they might have some factors that are in common. Okay, so a squared plus a minus 2. What would your two first terms have to be? A and a. Okay, only way to multiply to get 2? 2 and 1. So we just need to decide which one has to be positive and which one has to be negative. Plus 2 minus 1. Okay, we're going to do the same thing with the second. A squared minus 4a plus 3. A and A. Last term is 3. What's the only way to multiply to get 3? 3 and 1. What do the signs have to be to get a minus 4a? Yep, minus and minus. Okay, so now that we factored it, do they have anything in common? They have an a minus 1 in common, which means we could certainly just figure out what other factors need to be on there for them to be the same. So this has a plus 2, a minus 1. This has a minus 3, a minus 1. So we want to make them completely identical. So what factor would we need to combine on to this first one so that I could get them the same? Yeah, we need an a minus 3, because over here in the second fraction we have an a minus 3 that we don't have in the first one. So we would want to add on an a minus 3. So we'll do that to both the numerator and the denominator. Second fraction, what would we want to add on? An a plus 2, yep. So we'll combine that on to the second one. Now with these denominators where we have the stretch of factors, I'm going to suggest that you first combine the numerator and see if perhaps the numerator will have one of those factors in it that you can cancel before you distribute everything out. Okay? So, first fraction here, what will the numerator be? 7a minus 21, okay, over all of this. We're just going to let it sit there like that for now. Plus, next one, what will this one be? 5a plus 10 over all of that. Okay, so now when we combine like terms, what will we have? So 7a and 5a give us 12a minus 21 and plus 10? Negative 11. Ooh, 12a minus 11, will that end up being any of those factors? No. Okay. So it won't. We were hoping that it would so we could cancel, but it doesn't work out that way for us. So now we need to go through and simplify the denominator. So when we simplify the three binomials, we would start by foiling two of them. Well, look, if I FOIL a plus 2 times a minus 1, I just get a squared plus a minus 2 back, right? So let's just take a minus 3 times a squared plus a minus 2. Figure out what this is. So first distribute your a to each of the terms. So what do we get when we distribute a to each of the terms? A to the third plus a squared minus 2a. Then what should I distribute to each of the terms? The negative 3. Okay, so negative 3 to a squared is a negative 3a squared. Negative 3 to the a is a minus 3a. And negative 3 times 2 is a plus 6. Remember when we did this earlier in the year, we lined up the like terms so it was easy to combine. You certainly don't have to do it that way, but... So now when we combine these together, what would we have? We'd have a cubed. A squared minus 3a squared, what is that? Minus 2a squared, yep. How about negative 2a minus 3a? Minus 5a, and then plus 6. So there's our simplified answer. Does it make sense that we did not simplify that denominator until we saw that we couldn't factor anything with it? Does that make sense?